Okay, so we are still on the 22nd chapter, that is number sequences. Okay, and today we'll talk about the third type. Okay, anything that you did not understand in yesterday's class when we were talking about the quadratic and the arithmetic sequences?
No, it was there.
Okay, very good. All right, so now we'll talk about the third type, in which I said it would be neither the arithmetic sequence nor the quadratic sequence. It would basically be a combination. Okay, so we'll discuss, and obviously this is going to vary from question to question. So I'll do an example and then we'll do some past paper questions. Okay. The example basically is telling you that you have a pattern 1 square minus 0 square gives you 1. 2 square minus 1 square is giving you 3. 3 square minus 2 square is 5. 5 square, 4 square. Minus 3 square is giving you 7. And then you have 5 square minus 4 square giving you 9. And then the question is basically asking you to find the eighth and the nth line of this pattern. Okay. All right. Now, apparently it's not arithmetic sequence, it's not quadratic sequence, but we'll see that it would be a combination. Okay. So this is the first line. This is the second line. This is the third line, fourth line, and fifth line. Generally, we say first term, second term, third term, nth term. This time we have nth line. That is why I'm numbering the lines. Okay. So when the line is 1, it is 1 square. When the line is 2, it is 2 square. When the line is 3, it's 3 square. When the line is 4, it's 4 square. So it looks like there's a direct relationship between the number of line and this first entry, right? So I can write it that the nth line will have n square and then minus is in every line. What about this one? Yes, Saneem, what do you think about the second, about this one, about these values, 0 square, 1 square, 2 square, 3 square, and 4 square?
And minus 1.
Very good. N minus 1 square. Okay, excellent. So it is going to be n minus 1 square equals what? Okay. And what about these? 1, 3, 5, 7, 9. What do you think about these?
Plus 3.
Plus 3 what? Okay.
No, this is the quadratic sequence.
Okay, very good. You're going in the right direction. So it's 1, 3, difference is of 2, then 3, 5, difference is of 2 again, okay? Then 5, 7, again 2. So is it a quadratic sequence or arithmetic sequence?
No, arithmetic.
Very good, okay? Arithmetic because the difference is fixed. All right. So how are we going to find out the nth term for this sequence? Nth term for this one is going to be we'll use the general term formula for arithmetic sequence, which we did yesterday. So Tn was a plus n minus 1 into d, right? What is a? A is the first term of the sequence. So in our example, it is 1, okay? So it would be 1 plus n minus 1. And what is the difference? Difference is 2. So this will give, oh, difference is 2. This will give you 1 plus 2n minus 2, and that is 2n minus 1. This means that we will have 2n minus 1. Did you understand this?
Yes, I did.
Okay, very well done. Then can you please tell me that what would be the eighth line of the pattern?
We would substitute 8 in the place of n.
Very good, very good. Okay. So eighth line is going to be, it's n square, so it would be 8 square minus n minus 1, that is 7 square, equals to 7 minus 1, and this will give you 13. Not 13, 15 basically. Yeah, it would be 15 because 2 into 8 is 16 and then minus 1, 15. All right. Okay, now Turhan has just joined, so I'll give him a quick idea about this question. Basically, this is the very first example of random sequences. We're talking about random sequences. So the example has lines this time. It does not have terms. It has lines, okay? The first line says 1 square minus 0 square equals 1. The second line said 2 square minus 1 square equals 3. The third line said 3 square minus 2 square equals 5. And the question was this. Find eighth and the nth line of this pattern, okay? So in order to do that, we need to understand one thing, that the eighth line would basically be found by finding the nth line. And for the nth line, when we were at the first line, it was 1. At the second line, it was 2. So for nth line, it would be n square. Okay, just give me 1 second, please. I will get back to you. Okay. All right. Then the fourth line is what? 4 square minus 3 square, right? So this means that basically for the first line we have n square, for the second line we have n minus 1 square, and this is an arithmetic sequence with a1, that is the first term, and b is 2. So we calculated the nth term for this part using the general formula, right? And this is what we got. So did you understand this, Turhan? Yes.
Yes, ma'am, I understand.
Okay, all right. Now I am going to share some past paper questions with you guys on the group, and then I'll do them on white. Okay, so I've shared two past paper questions. Let's talk about the first one, that is the 23rd one. Okay, now basically this question is very much similar to what we have just discussed. So I'll just write down the question quickly. So it is a past paper question, and it says, the first four lines of the pattern of numbers are shown. And what are they? So the first line is 3 square minus 1 square equals 8 into 1. The second one is 5 square minus 1 square equals 8 into 1 plus 2. The third line is 7 square minus 1 square equals 8 into 1 plus 2 plus 3. And then the last one is 9 square minus 1 square equals 8 into 1 plus 2 plus 3 plus 4. Okay. And we have been told that this is line 1. This is line 2. This is line 3. And this is line 4. So this time, this is again a sequence, but we don't have terms, we have lines, okay? Part A says, write down the 7th line. Okay. Now for the 7th line, we need to understand one thing, that if this is the sequence 3, 5, 7, 9, there's a relationship between all these values. I'm adding 2 to get the next one. So this itself is an arithmetic sequence, right? So for finding out the 7th line, it is the first term, second term, third term, fourth term. Fifth term would be 11, sixth would be 13, and it would be 15, right? So this is going to be the 7th term of the sequence which I made out of the line pattern. Anything that you have not understood so far, please stop me. No questions?
We could have the 7th term by the nth term as well, that we found 2n minus 1.
2n minus, oh yeah, basically that would be 2n. Just give me 1 second. We did the previous example in which the question was yes, exactly. Yes, very good. We could have done that way as well, but the only thing which we need to understand is that this time around, first we have been asked to find out the 7th line, and then it says write down an expression in terms of n, right? So that's completely fine. You can do B part and then you can do A part, right? So yeah, that is also easy. But since this was just 7th line, so I was like, this would take less time than, I put the general formula and do it that way, okay?
Yeah, so it could be. So can I see the answer?
Yeah, sure, sure.
That would be 15 square minus 1 equals 8 times, and then brackets 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7.
Very good. So this would go on till 7. Excellent. Okay, because when we have 4th line, we have 4 here. When there's 3rd line, we have 3 here. Second line, 2 here. Very good. We will write down 1 square here. Okay, although 1 and 1 square are same, but still the line has 1 square everywhere. That is why we will write down 1 square. Okay, very good. Both of you. All right, let's talk about the second part. That is the B part. It says write down an expression in terms of n to complete the nth line of the pattern. So we need to write down this side, and they have told us that the other side would be 8 into 1 plus 2 plus 3 plus 4 plus n. So what are going to be the terms on the left side? Now we need to understand that this would be 1 square minus, and what about the first term?
N square.
N
or
square
n
would
square,
basically give you
any of these. It could be 4n square, 4 plus n square, because it's higher than 4.
all right, let's just check that out. Okay, let's just check that out. Okay, so basically we know that we have written down the sequence for this. It is this, okay, 3, 5, 7, 9, 11, 13, 15. Yes, we have squares, but we don't need to write down the squares because we just square the nth term, right? So what would be the nth term of this sequence? This is my question. So A is the first term, that is 3. Difference is 2. And the formula for the nth term is it's A plus n minus 1 into D. A is 3, n minus 1 and D is 2. It is going to give me 3 plus 2n minus 2. So this time it would be 2n plus 1. Okay. Now, Saneem, I would like to tell you that yes, you were correct in the very beginning, but this time we will have plus because our A is different. In the last example, the difference was of 2, but A was 1, right? This time A is 3. So the nth term would be 2n plus 1. This means that the nth term for this sequence is 2n plus 1. So since we are squaring every term, so we will just square the nth term as well, and we are going to get the correct answer. So this would be the square of the nth term. Okay, so this would be the nth line basically. Any confusion, Saneem and Turhan?
No, ma'am, it's clear.
Okay, Turhan, did you understand this now?
Yes.
Okay. Now, if we look at the C part of this question, it says, using the nth line pattern, show that 1 plus 2 plus 3 plus 4 equals n into n plus 1 by 2. So do you guys have any idea about this part? Anything that you would like to add? Okay.
Yes, ma'am.
Okay, yes.
So what we can do is,
Mm-hmm.
for that, we can add, so we can substitute n with anything. We can choose 5 to make it easier for ourselves. So we can do
Okay.
1 plus 2 plus 3 plus 4 plus 5
Mm-hmm.
equals n, 5 times 5 plus 1 over 2. And then we can work out both sides till we get the same number on both sides.
Okay, yes, I got your point. That is very good. But that way we are basically working for a specific n, right? They want us to show this
Yeah.
for n. Yes, your method is correct, and I do understand, but you might not get marks for that because this way you are just showing it for one value. Or at most you can just show it for 3, 4 values. But this for this question, you need to talk about things in general, okay? So let's try doing it this way. I'll just drop this just so I have some more space. Okay. So for this, let's talk about the third part. Using the nth line pattern, we need to show something. We'll show that. And let's just use the nth line pattern. Okay. So this is the nth line pattern. Let's talk about part C from there. Okay. Now we need to show this. We need to show that something over here equals this green part. Since I'm interested in this part only, I would like to separate it. So I'll just take this 8 on this side. And this is going to give me 2n plus 1 whole square minus 1 divided by 8. Okay. Let's see what exactly this is. This is equal to 1 plus 2 plus 3 plus 4 plus so on till n. So we are good at this side. We need to show that this fraction is basically n into n plus 1 by 2. So how do we show that? Anyone?
Excuse me, ma'am, why didn't you write -1 square?
Oh yeah, it is this. Okay. Was this your question?
Yes.
Okay. All right. So basically, for showing that, we will open this up. So 2n plus 1 whole square will give me what? 2n square. That would be 4n square plus 2 into 2n into 1. That would be 4n plus 1 minus 1. Now I'm not writing down 1 square because I need to simplify this and get what the examiner wants me to. Divided by 8. 1 and 1 would be cancelled. I can take 4 common and n common, and this will give me n plus 1 divided by 8. I'll cancel out 4 and 8, and finally I will get n into n plus 1 divided by 2, and this is equal to 1 plus 2 plus 3 plus 4 plus dot 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 plus n, right? So this is basically the proof, and we have proved that. So anything that you have not understood, please feel free to ask me. Yes, Saneem and Turhan.
Yes, it's clear.
Okay, very good. All right. Turhan, did you understand this?
Yes.
Okay. All right. So this was the first question. So I've already shared the second question with you. That is basically the sixth question of a paper. So I'll clear my screen and we'll talk about that. Okay. Now it says, these are the first 4 patterns in a sequence made using counters. Okay, so we'll talk about part A. Obviously, I'll not draw the patterns. I've already shared that with you. We'll just make this table and let's see if we're able to do that or not. Okay. One, two, three, 4, and 5. Okay. Now this says pattern number, and they have given us 1, 2, 3, 4, 5, and this says number of counters. Okay. So yes, we have been told that pattern number 1 has 3 counters, pattern number 2 has 8 counters, pattern number 3 has 15 counters, and we have been asked to complete this table. So how many counters do we have in pattern number 4? We need to count that, okay? We can count that. Now for pattern 4, we can see that we have 4 columns and each column has 1 row. Obviously, so we have, we will multiply 1, 2, 3, 4, 5, 6 into 4, right? We will basically multiply the number of rows into number of columns. So we have 6 rows and 4 columns, and this will give us 24. Okay. Now, for finding out the 5th pattern, we are not going to draw all those counters and do it that way. We'll see that from going to 3, from 3 to 8, we have to add 5. Then from 8 to 15, we need to add what, guys? 7.
7.
15 to 24, we need to add 9. So next time we'll be adding 11, and that will give us 24 plus 11 is 35, right? Okay, very good. Let's talk about the second part. So this time it says, find an expression in terms of n for the number of counters in pattern n. So what do you think about this? Again, number of counters is basically what? Number of counters has basically a quadratic sequence, right? So for finding out the nth term of a quadratic sequence, we are going to use the nth term formula. And what is the nth term formula? Tn equals a plus n minus 1 into first difference plus the fixed difference divided by 2 into n minus 1 into n minus 2, right? This is what we have discussed yesterday as well. So we need to figure out A, we need to figure out D1, we need to figure out D2. So I want you guys to figure all this out, simplify this and tell me the answer, okay? I'll give you 2 minutes for this. Let me know once you guys are done, okay?
I got n squared plus 2n.
And what about you, Turhan?
Almost done.
Okay, just complete this and tell me your answer as well, okay?
N square minus 2 plus 3.
Okay, let's see. The answer is basically what Saneem got. Okay, very good. Both of you tried and good, Saneem. Okay, so this is the general formula which you will use for every question where you will notice that the sequence is a quadratic sequence, right? So I'll use this. My A is 3. 3 plus n minus 1. First difference is 5 plus d2. The fixed difference between the consecutive differences is 2 by 2. N minus 1, n minus 2. This has 3 plus 5n minus 5 plus n square. 2 and 2 would be cancelled. Minus 2n minus n plus 2. This has n square plus 2n plus 3 plus 2, that is 5 minus 5. This and this, they would be cancelled and we'll be left with n square plus 2n. And this was the answer, right? N square plus 2n is the answer. So Turhan, did you understand your mistake?
Yes, I didn't cut out 3.
Okay. All right, no problem. So this is what we will have. I'll just write down the answer and then we'll talk about the last part of this question. This turned out to be n square plus 2n. Okay. The third part is Ken has a bag containing 1358 counters. Now imagine everything, okay? There's a bag in which we have 1358 counters. He makes the largest possible pattern in the sequence, pattern P, using these counters. Find the value of P. Now, the thing is that there would be a time when we will continue this table such that for pattern P, the number of counters are going to be not 1358 exactly. Like we do have 1358, but we need to see how many how big pattern will we make. Because right now you can think about it as this 1358. Okay, we need to figure out the value of P. So we know that according to the nth term formula, this is the number of counters when pattern number is n. Okay, so when pattern number is P, it would be P square plus 2n equals 1358. Right? Did you understand this? I'll repeat. Basically, the question says Ken has a bag containing 1358 counters. He makes the largest possible pattern in the sequence pattern P, and we need to find the value of P. So pattern number P is basically using 1358 counters, okay? So pattern N uses n square plus 2n counters. So when we have P, it should be P square plus 2P equals this. We will find the value of P by this. Basically it is a quadratic equation. So can you guys use the quadratic formulas or your calculators directly and find the value of P quickly, please? Okay, just take 1 minute and tell me the answers. P would have two values, and just tell me those values.
Um,
Hmm.
1 second. It's either positive.
Yes.
Ma'am, it's giving me one with like
Sure, sure.
minus 1 plus 36.83. 37.83
Yes. Okay.
or
It's basically minus 37.86. Okay. And the other one is
yeah, minus 37.86 and uh, positive 35.83.
very well done. 35.86 or 8. That's fine. Okay. Right now, I want you guys to understand something over here. This is either this is the p-value or either this is the p-value. What you need to understand is that the answer is going to be what? Yes, what do you guys think? What would be the answer? P-value would be what?
Positive one.
Sorry?
The positive one.
Yeah, so what would be? What would that be? 35.86?
Yes.
Okay. And what about you, Turhan?
It has to be the positive value. So positive 35.83.
All right. Okay. Okay. Let's see. The thing is that P is a pattern number. So pattern number cannot be in decimals, right? Pattern number would either be 35, either be 36, or it would be 37, 38. It cannot be in decimals. That should be clear. So yes, you are correct. This would be the answer. So now when I'm saying it should be in decimals, what should be the value?
36, positive 36.
Yes, this is what any student would have said, but the answer is 35. You need to understand this thing, okay? Basically, for such questions, you have to focus not only on rounding, but on the underlying concept as well. Now, Ken had 1358 counters only, okay? If we are saying it is P equals 36, just use P equals 36 and check how many counters would we need. For P equals 36, we will need how many counters? Yes. Please tell me. For P equals 36, how many counters would we need? We will use this formula. We will need 1368 counters, right? And he does not have 1368 counters. He has 1358 counters. So the question was, Ken has a bag containing 1358 counters. He makes the largest possible pattern in the sequence. With 1358 counters, he can go till pattern P only, because for pattern 36, he needs 10 more counters, right? So we don't have that. So the answer would be 35. Did you understand this?
Yes.
Okay, Turhan. For such questions, you not only have to focus on the rounding, but also on this concept that he has 1358 counters only, and he cannot make pattern 36 because pattern 36 needs 1368 counters. So for this, he is just going to make pattern 35 with how many counters? How many counters would be required for this? Just tell me quickly. Pattern 35 will have how many counters?
1295.
Check that again. Wait. Very well done. Excellent. Okay. 35, pattern 35 will require 1295 counters. So he can make 1295. He can use 1295 counters, but he cannot use 1368 counters, right? Did you understand this, Surhan and Saneem?
Yes, ma'am.
And what about you, Turhan? Yes, please feel free to tell me if you have not understood this. Turhan, are you there?
Yes.
Did you understand this?
Yes, ma'am.
Okay. Then the last part, which I did not share, of the question said, he uses all of the remaining counters to make another pattern in the sequence pattern Q. Find the value of Q. Yes. I'll write down the question.
Did you say the remaining counters?
Yes. Part D says he uses all the remaining counters to make another pattern in the sequence that is pattern Q. Full stop. Question says find Q. Now, guys, first thing is that what is the number of remaining counters? So basically, for C part, we got that he would be able to make pattern 35, which required 1295 counters. He had 1358. So how many are remaining? Can you please tell
63.
me? So what? 63. Okay, very good. Now 63 are the number of counters he has. Now again, we will just use this formula. N square plus 2n equals 63. 63 is the number of counters. We need to find this n. Instead of n, I'll write down q because we have pattern q. So q square plus 2q minus 63 equals 0. So we can use we can either do it by middle term breaking or by the formula. And you will get q equals 7 or q equals minus 9. So the answer would be q equals 7, right?
Yes.
Turhan, did you understand this?
Yes.
All right, I trust your words then. That is it for today. So these were some past paper questions which were related to this chapter.